What I'd like to talk to you about today, this morning, is blockchain technology. A little bit about myself. I run a consultancy based out of Oxford.
Welcome on the stage, Mr. Laurence.
Thank you again. I run a consultancy based out of Oxford, developing applications for the blockchain. We are hiring, so if you're interested in this area, please come and talk to me afterwards. What I would like to cover today is talk a little bit, first of all, about an example of a low-tech blockchain. So I want to introduce the ideas of what makes up a blockchain. If you understand those ideas, how they are special, you'll understand how applications written for the blockchain are special. And so that'll introduce the blockchain components. From that, we'll talk about an actual implementation of blockchain, which is Bitcoin. We'll move on to Ethereum. Then we'll look at some of the applications of Ethereum, and then look at some of the problems in this space and maybe some of the directions we're going through. Okay. If you doze off, if you fall asleep during my talk and you remember nothing else, the basic takeaway message is that the blockchain is all about providing a trust layer without the need for a central authority. I will keep coming back to this idea that we don't need a central authority, that blockchains are all about disintermediation. And it's all about providing trust. If you're thinking about writing an application for the blockchain and it's all about trust, then you've got a good use case. Okay, so let's start looking at an example of a low-tech blockchain. This is an example that people often use. It's an example of a currency used by an island in the Pacific. Not used anymore, I don't think, but it was a few hundred years ago. And they used to have these coins, like these large stones as coins. Obviously, you can't carry these things around with you. They are huge. Some of them, these are, I think, smaller ones, but you could get them very big. The general idea would be that you would have one of these set up outside your house, and this would represent that you had some value. If you wanted to trade with somebody, you would just do that directly with the person. So you would say to them, okay, I would like to buy your boat, and in exchange, you can have this coin. The point about this was that it was in a very small community. So all of this, the transactions people would know about. There was a gossip network set up so that if you made a trade, everybody would find out about it. So they would know that I now had a boat and that somebody else had the coin. So that's the first component of blockchain that is interesting. It really needs a gossip network, so all of the transactions can be passed around, and it has to be in an ad hoc manner. We don't want the system to fail if one particular person is not passing on messages. So everything is just gossiped around. Second idea, perhaps really the central point about blockchains, is the idea of a shared public ledger. So in this is an idea that we can get together all of the transactions and that everybody who is involved in the system will have a copy of this. So in the example of our coins in the island, everybody would remember what transactions had taken place, who owned what coins, who owned now a boat or whatever. And so this was shared in the sense that everybody could see this, they had it in their memory. This provides transparency, so everybody can be sure about the correctness of all the transactions that have happened. Finally, we need to think then, if we're going to take this forward, we need to think if we're going to bring this onto the internet, we have a problem. So in the case of our islanders, it was easy because everybody knew each other. They could be sure who they were talking to, who the transactions came from. They could be sure that transaction hadn't been interfered with on the way. But obviously in the internet, you get people who will impersonate other people. You're not really sure who anybody is. You may get somebody in the middle of the transmission of your transaction who will try to alter it. So an additional property we need for that is cryptography. Who here understands public and private key cryptography? Can I show hands? Okay, most people, I think. Good. So just quickly to say, the idea behind this is something that was developed mainly in the 70s, and it really has changed our lives. We wouldn't be able to do a lot of the things we do on the internet without this. The idea is that you create a pair of keys, a public and a private key, and these can be used to verify that a transaction you have sent hasn't been tampered with, and also it can be used to verify your identity. So in this example, we have Alice. She wants to send a message to Bob. To do that, she uses Bob's public key. Bob's public key is available to everybody. He distributes this, makes sure it's known to everyone. She encrypts her message with that. The message gets to Bob, and he can decrypt it using his private key. But only he can decrypt it, because it can only be decrypted with that private key, and only he has that. Similarly, you can do things the other way around, so the idea that if you've encrypted something with your private key, that can prove that that message was from you and nobody else, because only you could have used the private key to encrypt it, and then anybody else can use your public key to decrypt it. Okay, second part of cryptography that you need to know about that we use on the blockchain are hash functions. These are one-way functions, they're deterministic. The idea is that you have some input on the left here. You pass it through one of these functions. These functions are well known. There's nothing secret about these. Everybody knows how to use them. Everybody has them. And it produces a digest to the far side, a hash sum, that is unique to the input. So if you change anything, any bit in the input, you'll get a completely different output. So this is a way of fingerprinting data, in effect. And I'm sure you've probably all used this if you downloaded some software and you wanted to check that it was, in fact, the person who provided the software had intended, then you check against a hash sum. So this is a means we have for fingerprinting our data in the blockchain. So to summarize the components then that we should need to think about that are specific to blockchain and that make blockchain special, we have a shared public ledger that is it's shared by everybody. Everybody has their own copy of the data. Everybody can see it. It's transparent. All transactions involved are sent to everybody. They're sent around a peer-to-peer network. So this is an ad hoc network. Anybody can join this at any time. Anybody can leave it any time. That doesn't affect the network as a whole. And we have cryptography to make our system secure and tamper-proof. So that's what those give us. We have transparency. The state of our system is based on consensus amongst the people who are using it, and we'll come into that more in a moment. The peer-to-peer network gives us resilience. Because we have no single point of failure, then we can be sure that it is censorship resistant. Because of cryptography, we know that our interactions are tamper-proof. Okay. So all those great ideas, they've been going around since the 70s, as I say. People started to think of ideas, how to use this in the early part of the century. But it's really only in 2009 that this all came together with a concrete implementation, which was Bitcoin, which I'm sure you all know. Who owns Bitcoins? Anyone here have Bitcoins? A few? Okay, not so many as I thought. Okay. So, yeah, 2008, 2009, a paper was produced by a guy called Satoshi Nakamoto. I should point out that it is not this guy, so nobody knows who Satoshi is. Well, I guess one person does, but at least. But yeah, his identity is obscure at least. This guy was accused of being Satoshi and had to get his lawyers to deny the fact. Satoshi hasn't done much recently. He's sort of gone into hiding, I guess. Some people think he is an alien. Some people think he's a time traveler. Whatever. Anyway, he came up with Bitcoin. And in my mind, this has been fantastically successful. It's been running since 2009, pretty much without any problems. It's still going. It is being used increasingly now. So that was 2009, Bitcoin. And the public ledger, the way this was generally implemented, in an abstract way, the idea is that we had these series of blocks. We start from a genesis block. And in each block, we have a header and some transactions. So as the transactions are done in Bitcoin, as people send Bitcoins around, they're added into a block as transactions. The clever part is that when we produce a new block, we take a hash of the previous block, the data in the previous block, and we put that into the current block. So this provides a fingerprint of the previous block. This chains them together, hence the name blockchain. And this means that as you produce these blocks and these things are chained together, if someone malicious comes along and tries to give you a block that he has changed in some way, you can always check the headers. You can check the hash values in all the blocks and check that they actually do correspond to the data in the blocks. So you will always know if the data has been tampered with. So all of the blocks in the current Bitcoin blockchain, for example, you can go through and you can check that they haven't been altered since they were produced. Okay, so that's how it's the idea in general. In practice, they often use things, Merkle trees, fantastic data structures. I'm sorry this hasn't come out too well, very clear. But the idea is that you start with your leaf nodes of some data, and you hash these pairwise to produce the next level up, and so on, until you get to a root node. This is your top hash. from that, you can check the validity of all the data. So if any change is made to any of the data, you will find out about it because the hashes no longer correspond. So in this example, someone has tried to manipulate a value in the leaf node, and so when the hash values go up, at some point you'll realize that they no longer correspond to what they should. You'll realize that the data has been tampered with. Okay. If we're going to describe this in a little bit of detail about Bitcoin, the idea is Alice is going to send some Bitcoins to Bob. We have a block representing the state of the system in which Alice has 10 Bitcoins and Bob has 20. So Alice, as the Bitcoin goes on, she decides to send out a transaction to the network. She sends out this transaction to say she wants to give Bob some Bitcoins. This is sent out to the network and eventually will be added into a block, and you will update the state of the system. So this block here represents the latest state of the system, in which Alice has now given 5 Bitcoins to Bob, so he had 25, she now has 5. The state of the system is what is represented by the latest block, and that is the absolute truth about the system. Okay, and as each block is added, it is chained to the previous one by the means of the hash, as I mentioned earlier. If you look at this from the network point of view, if you imagine all of these dots represent nodes on the network, so people who have started up client software to use Bitcoin, so they're all connected together, they found peers, so they joined together. Alice is going to send her transaction into one of her local nodes, one node she's connected to, so she sends off her transaction. This is where the gossip network comes in. So this transaction is then gossiped around the network. People just pass on the transaction as they see it to people that haven't seen it. So it goes around and eventually will be put into a block. So one of the nodes will produce a block and that block will then get added to our chain. We have a chain down here at the bottom. And then eventually another block is produced somewhere else and that will get added into the chain and so on. And so we have a blockchain built up. But I said it was all based on consensus. So we have a problem. If we have the example again, so Alice has sent out her transactions over here. She's maybe in the US. She's sending out transactions in this part of the world. Someone over here, perhaps in China, they're sending out transactions. Obviously, there's going to be a delay between for the time it takes for people to see these different transactions. So we have a breaking consensus. So people over there have one view of the system. People over here have a different view. How can we solve this? How can we get a canonical view? How can we get our latest block to represent the absolute truth about the state of our system? This is where a process called mining comes in. And the process in Bitcoin is called proof of work and involves massive farms like this. They use specialist hardware. There are other methods. There's one called proof of stake. I'll perhaps go into that. But the idea is that we have our network and we have someone produces a block. But how do we choose this person to produce that block? So they're going to gather up all the transactions that they see. They're going to say, this is the state of our system. But how do we get that? How do we organize that? Because all of these nodes, they're all equal. We want to produce this in a fair way. We want to get some view of the system, as I say, that represents the absolute truth. But there's no central authority, so how can we organize that? Well, the way we do it, we have a race. Because we want to say, one of these nodes, we're going to just pick one node at random to produce this block, to say your view of the system is the absolute truth about the system. And then we're going to add that to our blockchain and say, because these nodes are equal, then we might as well pick them as anybody else. But how do we do that in a fair way without the possibility of cheating? So we have a race. So in Bitcoin, we do this process called proof of work. And what happens is everybody who wants to get involved in this race, they run special mining software. And that software involves solving a mathematical puzzle. And it is an incredibly difficult puzzle to solve. Effectively, what you do is you make a guess. You add that guess, it's just a number called a nonce. You add that number to some data in the previous block. That gives you, you then take a hash of that gives you a value. If that value is small enough, then you have won the race. And then you can tell everybody else that you've won the race. You can produce your block to say, I've won the race with all the transactions in that you see, and you can propagate that through the network. But it is incredibly difficult to solve this. So in Bitcoin, there are thousands of people running specialist hardware to solve this every second, running billions of guesses every second, and it takes them on average 10 minutes to produce a block. So yeah, so that's what we do. So we get someone, they will produce a block, and it will get propagated around the network. People will be able to see that they have produced that block, and they will check that nonce, they will check the hash value and know they have won the race, and they will accept that as being the latest state of the system. But we run into another potential problem in that we could have two people. So here we have the people producing a red block and a green block. Maybe they both win the race at roughly the same time. And so the green one produces his block, he's won the race, he thinks. The red one at the same time produces his block, he thinks he's won the race. They don't know about each other because there hasn't been time for the blocks to propagate. So again, we have a potential problem. We could have a failure in consensus here. We have a fork in our chain. So how do we resolve this? Well, we have a rule. So we'll say you have to mine on the longest chain that you see. So that means that when you produce a new block, you look at the chain that you see so far, and you add your block onto the end of the longest one that you see. So here we have both of them have produced them at the same time. They added their blocks to the longest one they've seen, which is the yellow one. But the next person that produces a block, perhaps they will, for whatever reason, they'll see the red block first, so they will add their block onto that one, because that's the longest one that they see. And as time goes on, this chain on the top here will dominate because it's the longest one. As other blocks get added, this one will continue. And so the top chain will dominate. That will be the one that will go forward, that we will accept as being the truth about our system. The lower block, the green block, that will just be dropped. That fork of the chain will just be ignored. If there are transactions in the green block that weren't in the red block, for example, that doesn't matter because all of the transactions that have been distributed, they all exist all around the system, so they will eventually get picked up. So if not in the red block, maybe they would have been picked up in the brown block. Okay. Now we do have a problem. So nasty guy, Stalin, he had as tyrants often do, he liked to rewrite history. Here's an example of him removing people from photos. Obviously, we don't want this to happen in our blockchain. Is this possible? Well, it is possible. You get this. One of the potential problems we have in blockchain is the idea of a 51% attack. What could happen is that our blockchain could be going along. We're mining blocks quite happily on the blue line here. Someone comes along, our cyber Stalin, and decides he's going to rewrite history. He doesn't want these blue blocks. Instead, he wants his red blocks. If he has enough power, he can try to do that. So what he would have to do is he would have to start producing red blocks as fast as he can. He would need an immense amount of power to do this. But he could start producing blocks and try chaining them to this block. So, for example, if he liked this block, thought that was okay, but didn't like the next blue ones, he could start producing a chain of red blocks. If he can do this fast enough so that this becomes the longest chain, then people, as they're mining, will start to follow his chain rather than the blue one, because that's the longest one that they will see. But the problem is for him is that he has to have an immense amount of computing power to do this, to ensure that all the time he can beat the rest of the world at producing a block, so that people will pick his blocks over all the other ones. So it does require a lot of computing power. There is the other disadvantage as well in the terms of an incentive, because if this happens, if somebody did this, say, I don't know, the NSA decided they're going to put all their computing power, and Google and everyone decided they were going to do all this to destroy, to try and take over Bitcoin, people would realize that this was happening. They would realize that the blocks were being dropped, that they had seen, and that another chain was predominating. The blocks were being ignored, for example. So they would realize it was happening. If this was happening with Bitcoin and you realized that the Bitcoin network was under attack like this, people would just stop using it. So if you're doing this from an economic point of view to try to increase the value of your Bitcoins or to give yourself more Bitcoins in some way, it wouldn't work because people would just stop using the system. The value of Bitcoin would drop to zero. It would be pointless. It would be useful if you were trying to destroy it, I guess, but other than that, it's probably not worth it from an economic point of view. So a lot of the public blockchains that we see, the incentive to be honest is an economic incentive. With private blockchains, we don't have that, but in public ones, the incentive to be honest is usually economic. Okay. So that was the state of the system, state of the game in around 2009, 2010. We started to see a lot of different coins proliferate. People started producing vanity coins with their name on it. Some people tried to extend the use of Bitcoin to do slightly different things, to do things it wasn't quite designed for. they're quite imaginative, or people try to use different consensus mechanisms. So instead of doing that race that I said, they would try to do different things. And so we had a lot of alternative coins coming out, people speculating on them, whatever. But really the next major milestone came in 2014 with Ethereum, which has been described as the world computer. The idea behind Ethereum is that this is a general computing platform built on the blockchain, that you can build applications that will run on the blockchain. But these applications are not restricted in the same way that Bitcoin scripts are. So the applications written on Ethereum use a Turing-complete language. They are essentially arbitrary pieces of code and can do pretty much anything. The way this is implemented, every node on the network has a virtual machine running on it, and your code that you produce, that you want to run on Ethereum, these are called smart contracts. It's often a misleading title, but you can just think of them as pieces of code. These smart contracts, you distribute them in the same way that you distribute a transaction in Bitcoin, so you'll pass them around your system. So imagine Alice here, she wants to write a smart contract, she's written it, she passes this around the system as a transaction. It goes to all of the nodes on the network, so that everybody using Ethereum then gets a copy of her smart contract, so they have a copy of her code that she wants to run. If Bob wants to use this code, all he has to then do, if he wants to call a function, is he sends in a transaction that says he wants to call a function on Alice's smart contract, and he will send in some arguments. That transaction will be passed around the network, and they will be run on every node on the network. So every node running Ethereum will take that function and run it in the virtual machine using Alice's smart contract. Now this, to some people, seems very inefficient. It certainly did to me when I first heard about it, because you're running exactly the same piece of code all around the world at the same time. It seems to be hugely wasteful. But the point is not about efficiency here. It is about providing consensus and about having trust in your computation. And because we start from the same state in this virtual machine and we run the same piece of code at the same time, we will always end up at the same state. So you can be sure, you can have trust in your computation. There is transparency involved because everybody can see that smart contract. They all have a copy of it. There is transparency because everybody can see the call that Bob made, because it came in as a transaction, and they can see the arguments he supplied. So they can be sure that that transaction, that call to the function, has run correctly, and they can be confident about the result, about the state of the system. Okay, so people use Ethereum for various things, and the typical examples are you might have some underlying asset you want to digitize. You'll have a smart contract that perhaps issues tokens in return for a currency. The currency used by Ethereum is called Ether. It's built into the system, so support for that. Investors will then give some Ether and get some tokens in return, and maybe that will give them some rights on the underlying asset. And I'll give you lots of examples of applications of how this works. But as I'm sure you'll be thinking, this is open to abuse. So what happens if someone wrote a smart contract like this? So they wrote their contract with a function which has an infinite loop. They could put this into the Ethereum network, pass it around so it was available to everybody. They could then call this function, and then everybody would have to run this on their node in the virtual machine, and it would just loop forever. You would effectively DDoS the entire network extremely easily. So to get around this, we have a concept called gas. The idea behind gas is that each computational step in Ethereum has a cost. Every time the virtual machine executes an instruction, it has a cost in gas. The cost depends on the instruction. So, for example, to add two numbers is relatively cheap. To actually store some data in your smart contract, to update the state of your smart contract, is expensive. And at the beginning of your transaction, the person calling that transaction has to provide this gas in the form of Ether. So he provides some Ether up front, and as the function runs, the virtual machine will reduce the amount of gas that he has provided. If that reaches 0, then the transaction, the function is stopped, the transaction is rolled back to the previous state. Also, there is a hard limit as well, so that even if you provide a huge amount of gas, you couldn't go on running this thing forever. There's a hard limit to the amount of execution steps, the amount of computation that you can do. So in that way, we can stop people having infinite loops. We can stop people from trying to store vast amounts of data on the Ethereum blockchain. Typically, the idea when you're writing blockchain applications on Ethereum is to keep your functions small, only do on the blockchain what you have to do, only store as much data as you really have to store, because it can be very expensive otherwise. And it does have a real-world cost, because you have to provide Ether up front. Okay, what does this look like? Well, this is an example of a smart contract written in a language called Solidity, which is the most popular language. This one is part of a contract to write a cryptocurrency. Writing one of those in Ethereum is incredibly easy. But you write a contract, you compile it, it produces bytecode, it looks like that. It's the bytecode that gets sent out as a smart contract to all the virtual machines, and it's the bytecode that is then run in the virtual machine when you call the functions. Okay, the stack of Ethereum, if you imagine, so this is a node. There's different software to run a node, two particular ones, Geth or Parity. But your node will have all the blocks, it will have all the contracts. You can then call this from JavaScript libraries. So there's Web3.js for JavaScript, there's Ethereum for .NET libraries, some Python libraries. They connect to the node via remote procedure calls over HTTP. Because you've got your JavaScript libraries, then you can call them from HTML. So that's the sort of typical stack that people use. Developing tools, I'll do a talk about some of these later, but typically there is a useful tool called Remix, which is a browser-based compiler. You can write your contracts and compile them and deploy them for you. Other things, a very useful one is Truffle. It expands on that. It allows you to write your contracts, compile them. It also allows you to write unit tests, and it also gives you some boilerplate web framework as well. MetaMask is a plugin for Firefox and Chrome, which provides you with a wallet, and it allows you to interact with the Ethereum blockchain, the test networks and the mainnet. So Visual Studio also has support for Solidity. Best practices. There's a great project, Open Zeppelin, which is trying to improve best practices in this area and provide good patterns. We are at fairly early days, so there have been a lot of problems. People have finding bugs in their applications, so best practices are very much needed. There's quite good documentation around Solidity, so going through good ways to withdraw Ether, for example, from contracts. Just to give a shout out for some workshops I do, where we do workshops in London to try and help people in this space. One problem that you have, we talked about, so these smart contracts are sent around, and the smart contract starts from a known state. We run a function and we go to a next known state. So the contract has to be deterministic. We're going to have consensus amongst all the nodes on our network. Then we need to be sure that our contract is deterministic. So we have a problem with getting data. Obviously, when you write an application, you want to go to the outside world and get some data to compute. We can't do that with Ethereum, because you could have the example that this node would try to get some data and would get hit by have maybe a firewall or something, couldn't get the data. Other nodes could get the data, so straight away you would have a consensus failure. The network would have a split. We'd have different views of the state of our system. So going to the outside world is not allowed in Ethereum. You cannot go and get data from outside. You cannot read from your local file system. You cannot look at the local operating system. The way you get around this is that you have to get some external system to send in data if you need it. So you have things called oracles that will send data in. They send that data in as a transaction, and in that way, everybody will get the same view of the data. They all get that transaction, so they can then all update their system, their local copy of the system in the same way. Another problem we have is around privacy. As I said, every transaction on the blockchain is seen by everybody. So if you have data that is private, it's harder to implement. The way you get around this typically is that you would have to encrypt data before you put it on the blockchain, and that way you can be sure it is private. This is typically a problem here in Europe. We're seeing the GDPR regulations coming in, so it's quite hard for if you're writing applications to make sure you're going to comply with those. If you want to, I've talked about computation. If you want to store data, that's difficult on Ethereum. It's very costly. You don't really want to store more data than you need. There are alternatives. So the alternative on Ethereum, although it's still in alpha, is called Swarm. And this allows you to store arbitrary amounts of data. One that is more advanced, more mature is IPFS. It's a great system. It allows you to store arbitrary amounts of data in a decentralized manner. The idea behind it is that when you put the data on there, the address of the data is given by the hash of the content of the data. So if two people put the same piece of data there, it effectively is gets the same address, so you don't get any data duplication. There's also another example, Storage. Also went through some seed funding lately, and there's another alternative if you want to store data. Ethereum is not the only blockchain out there for computation, some other alternatives. Hyperledger, which is very focused on the enterprise. It's done by IBM, the Linux Foundation. I think there are going to be talks about that later. Lisk allows you to write contracts in JavaScript. IOTA focuses on IoT devices. Tezos has the idea, they really focus on the idea that one of the problems behind blockchains is governance. How do you change the protocols of the blockchain as you're going along? So they have tried to put in means of doing that, but they have recently been, I don't know if you've been following the news, but they've recently been involved in a lot of controversy. They raised a lot of money, and there's a lot of arguments going on about that at the moment. Okay, so as I say, Hyperledger are very much focused on the enterprise. Ethereum, when it came out, was not so focused on that. And so about 9 months ago, the Enterprise Ethereum Alliance was founded to try to increase the research and the ideas for Ethereum in the enterprise, backed by a lot of big companies. So they're trying to... It's not necessarily changing Ethereum, but they're producing ideas and helping Ethereum into enterprise applications. The thing people always ask me, and they've been asking me this for a couple of years, is this just a load of hype? And it's a valid question. You should be asking this. So this is the Gartner hype cycle. You should be familiar with this. So this is from 2016. At the time, blockchain was up here, almost peak hype. It still seems to be there. Hasn't really changed. So I don't know whether that means that this axis is maybe a log axis or something, or time is going very slowly. There is a lot of hype around blockchain at the moment, but I think it obviously has a great deal of real value as well. A lot of the hype we're seeing at the moment is around ICOs, which I'll talk about in a second. But do be aware of the hype. Do be careful. Do look into this technology if you're going to use it. But there are real companies using this now. So one company that I've worked for, Sane, we recently, or back in the summer, we run a project to do a pilot project with Porsche. This is a picture of me holding a large cardboard check. A lot of companies are getting involved. They want to get pilot projects going, get some exposure to blockchain, because they're worried that their competitors are going to be doing the same. They don't want to be left behind. They want to know what this area is all about. These are some just news items I picked out from the summer, a lot of different areas. So supply chain is a good example. People are getting into that. Central banks are certainly getting into blockchain. Advertising, insurance is a great application. If anybody here is from London, there is a currency out in London now that you can go and pay for businesses, local restaurants, etc. So this is a photo of me outside a restaurant paying for my lunch with a cryptocurrency that is just for East London. If you're interested in the applications that are on Ethereum, there's a good site called State of the Dapps. This is where people promote their own application that they're running. There's some good ones. So Ujo Music, this is by a company called Consensus, who do a lot of development on Ethereum. So the idea is that people who write music, who want their royalties paid, can use this application. They'll get their royalties instantaneously rather than having to wait. Decentraland is a game application. There are lots of different things, so I'll go through some of those in a second. If we look at fintech, this was really where people saw the application of the blockchain initially. Banks jumped into this area, first of all, because they saw it as a great means of reducing their costs, particularly around clearance and settlement. And they could get into consortia blockchains to get rid of clearinghouses. Central banks are very I'm very into this. So this is from the summer where Russia were talking about this and Vietnam. This is a headline from yesterday about the Federal Reserve thinking about using the blockchain. Bitcoin is useful because when people are managing assets, they often like to get things, put assets together that have a low correlation so they can diversify their portfolio. So they will try equities and bonds, for example. And they found that Bitcoin has a very low correlation with everything, so it's a great addition to portfolios. So people are moving in and trying to add this to their portfolios. Melonport is an application written on Ethereum, which is an asset management suite that allows you to build up your own portfolios. A nice example from insurance. This is Ether Risk. The idea behind this is if you're going to get a flight and you're worried about it being delayed, you can call up this smart contract. You put in a small amount of Ether as a premium. This contract monitors the flight delays via Wolfram Alpha. The instant that the flight is recorded as being delayed, the smart contract will find out and will pay out compensation to you in the form of Ether, and it will be done in seconds. So you don't have to apply to anybody to get your compensation, to get your insurance. It will just happen in seconds automatically. Very nice application. Another great application that's been around for quite a long time, was one of the first ones to come about, is around supply chain. This company is called Provenance. They've been around for a couple of years. The idea is that each step in the supply chain can be tracked on a blockchain, and with that tracking you can be sure about the integrity of a component. So say I'm looking at components in my laptop, I want to know where they've come from. Are they genuine? Have they involved child labor or whatever? You can use a blockchain to track those. Now, the thing about that, and the thing that people always ask me is, or they always say, well, obviously people could still be dishonest. They could introduce a component, put it on the blockchain and say, yeah, this is genuine, when it isn't. And of course they could. You still have the human element there. But what I think the blockchain adds in this case is that if you are adding that transaction into the blockchain to verify that component is valid, is a real component, and you're signing that with your private key, that will make you a little bit more honest, I think, because you're effectively putting your name against that. You know that transaction will be there for all time and will be able to be seen by everybody. So you can't go back in future years and say, oh, it wasn't me, or I didn't mean to say that. You really are signing and putting your reputation on the line by adding that. So I think it makes people more honest. So I think supply chains are a valid use case. This is a great one anyway, Provenance. Check those out. They do supply chain against all sorts of products, things like food and but any kind of products. Energy is also a great way to use the blockchain. People like the idea of having being able to sell small amounts of energy. If they produce energy, they want to be able to sell that to other people. So they like the idea of a decentralized market to sell their energy. There's a company in London called Electron who are looking at smart meters and are looking at demand side response. So the idea that you can reduce your need for electricity and get paid to do that, and all of that will be done on the blockchain. You can get micropayments done automatically and instantaneously. Another use case that we see a lot of, gambling. People like doing lotteries and various types of gambling on the blockchain. If you see these though, and you're interested in one of these applications, ask them how they do their random numbers, because that's very difficult to do on the blockchain. As I said, in an Ethereum smart contract, the contract has to be deterministic, so random numbers can't be done, or not easily. You have to be very careful how you do those. So if you want to take part in a gambling application, check it out very carefully. There are lots of ways to get around it, lots of ways to front-run transactions, for example. But this one I'm sure is fine. Lots of games coming out on Ethereum, and a really old one was called Ethereum, where you could buy tiles and set up your own little virtual world. The new one, Decentralised, something that's just come out very recently, CryptoKitties, the sort of Tamagotchi idea on Ethereum. One of my friends recently described it as either the best or the worst thing on the blockchain at the moment, so make up your mind on that one. Democracy, voting systems, a great application, easy to do. Because of the transparency, because of the mutability of the blockchain, you can see the votes have been done correctly. You can see that there's been no corruption. This is an example of Democracy Earth. Their identity on the blockchain is a difficult problem, but people are starting to do it. Estonia are getting into this space, so you can apply to them for an e-residency. They will give you a card, and then you can use this to prove your identity. And applications on the blockchain tend to trust this. ICOs, so there's been a lot of hype about these recently, particularly in the last sort of 9 months or so. They really have become very successful. Huge amount of money has been raised. Now 1.7 billion was the value in the summer. It's a great deal more now. Some examples, this again was in the summer. The largest one at that point was Tezos, which had raised $200 million. There have been more since then. Filecoin raised more. The amount raised per month here shows just an incredible amount of money is being raised at the moment via ICOs. I'll just skip through these. This has affected the Ethereum price quite considerably. If you look about here's where ICOs started to be used a great deal, and the price has just rocketed up to, we're almost, $400, $500 now. Down, we were just a few dollars a couple of years ago. This has produced problems. One famous one with decentralized, we had decentralized autonomous organizations. About 18 months ago, a particular one was introduced. This was a particular application on the blockchain. It had no employees. It was completely autonomous. It was a crowd-funded idea, and it managed funds for people. People would propose projects, and the DAO would automatically and autonomously provide them with money. When it was created, I took this screenshot, and it had raised $220 million. This was money that this contract, this piece of code owned and had complete control over. No human had any control over that amount of money. Of course, what happened was that we had problems. There were security problems. These symbols represent Ethereum, the DAO, and Bitcoin. So what happened? The security problems, someone worked out a way to manipulate the system and start to steal a lot of the ether. We also have had problems more recently in a wallet. So this was from the summer, and there's been one more recently where funds have been stolen. This is a problem not with Ethereum itself, but with applications written on Ethereum. One of the things is that when you write applications on Ethereum, you have to be very careful. You have to think about the game theory involved and understand people's incentives to how they're going to be using your applications. It's very difficult when you're writing applications to think of all the eventualities. Once you've written a contract and you put it out there on the blockchain, you cannot change it. So you have to be super careful. I always say to people it's like writing software for a satellite or something. Once it's been written, you can't change it. You can't go back and fix any bugs. So you have to be extremely sure that you've done it correctly. We had somebody stole some ether, and then we had a group called the White Hat Group who have been around since the DAO hack, and they went in and tried to also do the same exploit, but to take the rest of the money out of this problem wallet and to save it and give it back to the people who are involved. So they're trying to be the good guys in this. There are a lot of scams going on in ICOs. Be extremely careful if you want to invest in an ICO to make sure that you are investing in what you think you are investing. People are duplicating projects. They are doing the usual sort of phishing scams. But because this is done on the blockchain and people can't trace easily where money is going, they're getting away with lots of scams. The SEC is starting to rule on ICOs. I think people are going to start going to jail, and as a result, I think the ICO bubble is going to start bursting, which is going to be a good thing. Recently, there's been a fork in Bitcoin. Just to talk a little bit about governance very quickly. The problem was that there were Bitcoin blocks would fill up very quickly. The scalability issue. People were very conflicted as to how to solve this. Eventually, the community split, and we got Bitcoin Cash as well as Bitcoin. One interesting feature that happened was that people who were doing mining on Bitcoin and Bitcoin Cash, as I say, as this mining happens, it's a race to produce a block, but the difficulty in producing the block can change depending on how long it takes to produce a block. So in the Bitcoin network, we try to keep that to 10 minutes. If that time is becoming too long, you reduce the difficulty. If it's becoming too short, you increase the difficulty. What happened with Bitcoin Cash is that because there were few miners on the system, they had to reduce the difficulty because the block time was becoming huge. As soon as they reduced the difficulty, a lot of the miners from Bitcoin jumped in and said, oh, great, we can all start mining on this, produce lots of blocks very quickly, we get a reward for producing a block. So a lot of miners piled in to Bitcoin Cash, started mining on that, producing Bitcoins very quickly. So as a result, the block time for Bitcoin Cash dropped, the time for Bitcoin increased, and then the difficulty for Bitcoin then had to drop to take account of that, and so the miners then piled back into Bitcoin. And we've got this sort of seesawing effect of people, and this is represented here by these lines going back and forth, up and down, where miners were jumping between the two systems as the difficulty changed between the two. So it became quite an unstable pair of systems. Interesting areas now to help with scalability. We're getting the Raiden network on Ethereum, which is using state channels to take transactions off the main blockchain and run them between two counterparties, and then put the results back on the blockchain. So this will allow greater scalability and to allow counterparties to do lots of transactions much more quickly. On Bitcoin, there is an equivalent thing called Lightning Network. A very interesting area, one that is getting a lot of research, is around zero-knowledge proofs. And one cryptocurrency that uses this is Zcash. So with Zcash, you can have the thing now where you can send a transaction in to give people some Zcash, but the way it is, even though effectively on a blockchain you think there's transparency, but with Zcash what happens is you can hide the identity of the person sending the transaction, you can hide the identifier of the recipient and the amount of coins that was transferred. But the blockchain itself, via zero-knowledge proofs, can prove that transaction was valid, that it hasn't been tampered with. Okay, I think I'm pretty much out of time. If you have questions, I'm happy to answer them. You can come and ask me afterwards. You can also contact me. That's my details. As I say, we are hiring, so we're looking for developers to train in this area. If you're interested in developing on Ethereum, please come chat to me. I'm doing a talk about some of the development tools later, so please come along to that. And thank you for your attention. Thank you.